Okay, we are in a discussion of AWS Solutions Architect. And my previous video, we've been discussing about the development of a coding process over the time, right? It's been, we discussed the main like the terminology of coding, modern coding deployments. And then we discussed about how the coding methods been evaluating from we using a local machine to cloud-based repositories. And now today we're just going to discuss a little bit more about the process, and we're going to looking into some sort of examples how the interfaces looks like, going to be from a viewpoint of solutions architect. So the main target of this video is to get an idea about the future videos which I'm going to do soon with the AWS code build, AWS code pipeline, AWS code deploy, and AWS code commit. So this is sort of a background video, the second part of a background video, which is going to have a look more into this detail. So I've got a few screenshots here. Just going to go into the description and come back to this screenshot. So this is some screenshots is taken from GitHub code deployment examples. They're just like examples. I want to see, I want to show you some interfaces. So the first one we're going to have a look is a workflow visualization. So GitHub Actions display deployment workflows with visual graph showing build, test, deployment across multiple platforms. Right? Let's have a look. See that this is a deploy.yml. So you got different builds, right? And then integrations here, and then so deployment stages. So this is initialization, right? So this is test. Three of three jobs are completed, right? And then so multi-stage deployment process showing build test on Linux, Mac OS, and Windows, and approval gates before production release. So that's what I explained. So let's go into that screenshot. So this is a build deploy YAML file, and see that this is building with the testing with the different operating systems. So build Linux, build Mac OS, and build Windows. And then before we publishing, right? So Linux is waiting for approval, and publishing Mac OS waiting for approval, and also publishing Windows for waiting for approval. That's what here explains. So multi-stage deployment process showing a build test on Linux, Mac OS, Windows, and approval gate with production release. And then these last two pictures I'm going to show you is a workflow editor. So YAML-based workflow configuration interface with the trigger event selection and environmental variable, right? See that these ones is going to be workflow. This is one of the GitHub account, and it shows you how the workflow. So see this is push and setting up an environment, right? So on-demand workflow trigger. GitHub Actions UI showing recent workflow runs with option to manually trigger deployment from my specific branches, right? See, you can see the working interfaces of these deployment. So they are in possibly a web-based interfaces, right? So that is some sort of screenshots, right? So let's have a look at understanding the DevOps CI/CD pipeline. So that is the pipeline which is going to be from code to production. So source control trigger is the first step. So develop commits code to a repository, This triggers the entire automated pipeline initiating build and test process. So the process is started with when you commit code to a repository. So you copy your codes into repository and then you start this pipeline process, right? So that's the first one is the trigger. The second one is a continuous integration. So build is compiled and packaged, right? Second step as it automatically triggers the compilation and packaging like dependencies, and then you go to automated unit and integrated test run, right? And then you have a quality checks in number two, code analysis and securing scanning pipeline is stopped if it's failed. So it's a security checking in here, number two. And then number three, once this process completed, so it will create artifact creation. Artifact can be a software package, it can be a container, right? So successful build procedure artifact. So Docker image, package or archives or compiled binaries, right? That's a version and it stores in a registry. So the registry pointed to a version that you are using. And then I use staging. Number four is staging. So staging is that created build is deployed to a pre-production environment, right? Once this environment, production environment testing is done, then it's waiting for approval, right? So automated gates, and then the next process is the production. So automatic deployment after validations might be um, blue-green production or might be straight away production. So speed, right? So that speed is not a weeks, minutes, reliability, right? Automated testing catches bugs early in the cycle. So consistency, same automated process every time, reduced errors, right? And then finally, once you set these your package into production level, then monitoring and feedback sort of things coming up. That is sort of continuous with deployment. I mean, development is coming up, like you finding out performance issues, errors, health, right? So then coming up in future development cycles for continuous improvement, right? So, how source control fits into the CI/CD pipeline. So, this is again we can looking in like a flow chart diagram. So the source code in here, GitHub or somewhere, and then you commit changes, and then build the stages coming up. Then it's building, and then you going into a pre-production the automated test for and automation technical, including code analysis and security scan for vulnerabilities. And then you're going to have artifact repository, so various versions of a created software, compiled binaries, like a Docker image, something like, and then you going to deploy it in a deployment to a staging pre-production, and then you're going to deploy it in production environment, and then you're going to go to monitoring logs, right? And central role of source control. So source control serves as a trigger and foundation of every CI/CD pipeline. When developers push code to a repository, the automated workflows are initiated, right? So detect code changes, right? And then launch build process, and then execute test suits, and then prepare artifacts for deployment. So Git workflows and branching, right? pull requests and merge strategies enable collaborative deployment development while maintaining code quality through peer review. And then a webhook triggers, right? Webhook is automatically notify, push, initiate the pipeline execution without manual intervention. The pipeline is the process is starting to make source code into a production type software, right? And then the branch protection rules, right? Enforce CI/CD checks approvals before merge it to a main branches, ensuring only validate code reaches production, right? All right, so we just have it's a quick comparison of GitHub versus GitLab, right? So GitHub is a cloud-based software as a service platform which extensive marketplace integration and native project planning capabilities. So many things. It's a cloud-based one. You can create account. GitLab is a self-hosted or cloud option with integrated DevOps feature, including CI/CD pipeline and security scanning built in. This one you have like the paid version, right? Key comparison: repository management integrate DevOps capabilities, right? And deployment flexibility. Both platforms support cloud hosted and self hosted models for enterprise flexibility, right? So they all provide flexibility. Okay, so then we have Jenkins, like open source one, right? Versus GitHub Actions. So Jenkins is a open source legacy standard with extensive plugin ecosystem for custom workflows and integration. Higher maintenance overhead requires self-hosting and infrastructure management. Prone is scalability with large enterprise potential vendor lock-in considerations, right? So GitHub Actions, cloud native integrated direct with repositories, 17,000 plus pre-built actions available in marketplace, minimal maintenance, GitHub hosted or self-hosted, runners with reduced operational complexity, modern scaling for multi-OS deployment and desktop applications. So that is what is the options. So many options you have with this one, right? Okay, multi-cloud deployment services, AWS. AWS got, as I said, in where we head into. So code pipelines is orchestrates end-to-end CI/CD workflows. We're going to discuss in a separate video. Code build is same thing like manage build service for complies, complete compilation and testing. Then code deploy automates application deployment to instance and on-premises servers. Code deploy, what code deploy does is um, push the codes into a different compute services like Lambda, EC2 instance, ECR, uh, and then containers, and then Kubernetes, right? The base fit containerized web application with AWS native ecosystem. So challenges, artifact size limitations, lack of native macOS environment in code build, complexity for multi-OS applications requiring desktop cross-platform builds. So that's what they have. So multi-cloud deployment services, right? Like Azure and Google Cloud. Azure DevOps is enterprise focused with advanced role-based control for complex organizational structures. And then you're going to go Google Cloud Platform, Cloud Build, and Cloud Deploy for containerized workloads and Kubernetes in native deployment, right? Something here, but it doesn't build properly. Sorry for that. Okay, so integration strategy, right? CI/CD orchestration. So this is how the things happening, right? So external CI tools like it use Jenkins, GitHub Actions, and then unified pipeline orchestration. Here you can do automated testing, building container, and then deployment, right? Argo CD GitOps, right? And then Kubernetes deployment from here. Then Helm charts configuration. So cloud deployment services integrate with the external CI tools to create unified pipelines. So you can use external tools, Kubernetes-centric strategies, leverage Argo CD, and Helm for continuous delivery with the uh, GitOps principles. All right, so case study, choosing the right platform. You just need to choose the right platform according to your organization. So whether it's a open source multi-OS or GitHub Actions ideal for project requiring cross-platform support and community contributions. So this one is the best for cross-platform. If you're using like different platforms, Windows, Linux, right, Mac OS, the best place. Enterprise consideration. So Azure DevOps or GitHub Enterprise, vendor consolidation and centralized governance. This one is a better. The AWS only stack leverage native code pipelines, code builder, code deploy for containerized applications within AWS ecosystem. So this is basically very good for AWS containerized applications. It can be ECS or EKS, Elastic Container Service, or Elastic Kubernetes Service in AWS. So we got a sort of picture here. So you have a local machine here, and then you got code push, code commit through GitHub, and then a webhook started the pipeline testing. And here you have a Jenkins, right? And then here you have a container registry and hub, right? So Docker build, Docker push, use this one. And here um, dev production environment, right? Kubernetes Docker images pull and push. So sort of an idea, right? How does work? All right, lesson learned from a real world platform decision. So what are the lessons we can learn from real world scenario? The shiny tool trap. So organization often adopt cutting edge platform without evaluating existing team expertise. Results steep learning curves, productivity loss, and eventual tool abandonment. Right? Lesson: choose platform that complement existing skills first. So sometimes the organization decide to go with the different platforms uh, without knowing that the capabilities of their team expertise, and then they're going to have a problem with learning that tool, and then you're going to lose your production loss. So evaluate the tools before you're going into the best suited tool for your organization, right? And then ignoring lock-in risk, right? So proprietary uh, CI/CD tools or deeply integrated platforms create vendor lock-ins, limiting future flexibility. Lesson: prioritize open standard API first architecture and cloud agnostic solutions. So when you're selecting the expensive proprietary tools, don't get into locks in them, because then you can't get out from that. So you're going to be expertise in that one. However, the price increase, you probably have to use the same thing. So that is you're probably going to lock into that vendor, right? Make sure you looks into a open standard. The open standard can be compatible with few different types. If you getting locked into one contract, so if you know the open standard, so you can go to some other platform. So neglecting security in selection. So platform chosen for speed often lacks compliance certification, audit logs, and RBAC maturity, causing painful retrofits later. So make sure you selected the platform with the security. Sometimes in the way of a middle after developing your product, you possibly have to go with the compliance with the some of the certifications and make sure these ones compliance with those certifications in the middle of a journey. If it's not compliance with the certifications, you possibly have to rebuild everything using a different platform. Might be costly, and then underestimating migration costs. So switching platforms require rewriting workflows, uh, retraining teams, and managing legacy integration. So hidden cost often exceeded initial savings. So run parallel system during transition and involve teams early in selection. Make sure you're testing with the different parallel systems to understand the compatibility, right? Otherwise, in the middle, if you're going to switch the platform, it will cost you more. So your initial savings going to be useless, right? Over engineering for scale, so team build complex with scalable platform before problem validation. Start simple, measure bottlenecks, and then iterate. Begin with manage SAS, self-hosted only when necessary. So think about your scale in your organization, right? And then decide accordingly. Don't do it over design. So start with simple and then see you can grow. Fragmented tool is power, right? It's power, right? Using separate tools for each pipeline stages, right? Create operational chaos. Best practice consolidated around platform suites that integrate natively, right? So separate tool for each pipeline, create operational chaos. Best practice to consolidate into your platform, right? Platform suites that's integrate natively, right? So consider these reasons where consider think about these reasons wisely before you selecting a platform. So winning is strategy. Define success matrix first. So pipeline is speed, deployment frequency, failure rates, team satisfaction, involve stakeholders, developers, ops, security, and financial platform selection. Pilot before committing, test finalist with the real workloads, right? Ensure reversibility to avoid permanent mistakes. So these are the consideration I think you have to think about when you're selecting a platform. So uh, briefly going to discuss future trends and conclusion before ending this video. So cloud native CI/CD in a rise, right? So it's a decline of traditional dedicated CI server in favor of managed serverless solutions these days, right? Tools like Argo CD enable true continuous delivery through GitHub patterns. Multi-cloud strategy architectures is spanning AWS, Azure, and Google Cloud Platform require flexible agnostic tooling, pipeline observability, enhanced monitoring, and cost tracking across distributed deployment pipeline. So key takeaways are choose platform aligned with organizational scale, so infrastructure preference and team expertise. Invest in platform configuration, consolidation, and automation first culture for sustainable DevOps maturity, optimizing pipelines continuously for speed, reliability, and cost efficiency. All right, I believe so. These ideas will give you uh, bit of a picture what is happening is today's development world, right? What are the process development been into here? I believe in the future, so AI will be coming into this sector as well. So we probably will get AI integration boards, and possibly one day the developer's life going to be very easy. He just possibly need to develop a flow chart for what he needed. So possibly AI will generate all these scripts and all the coding for and deployment. So that's where we are heading, I believe. So with saying that, I think I'm going to finish today's video, and hopefully we got enough knowledge to go ahead and discuss with my next few topics: AWS code build, AWS code pipeline, AWS code commit, AWS code deploy, sort of topics, right? Um, we'll see you guys from those videos. Until then, thank you very much.